So in this video, part D or P4D or P4 part 4, all we're really doing is tying it all together and doing what's called factoring completely. And what's going to happen is that all the other videos in this section were broken down by type, binomials, trinomials, grouping. Now you're going to find yourself doing them all together, and sometimes in the same problem, you're going to do multiple different kinds of factoring out a GCF, factoring a trinomial, maybe having to continue. So it throws it all in together. So we give you this little checklist on how to kind of like a guideline for you. First of all, when you look at any expression, the first thing you're always going to do is you're always going to check for a GCF. That is step one every time, okay? You cannot forget to check for GCF. It's not always going to be there, but if it is, it's going to simplify your process. Even if you have more to do than pulling it out, but at least it'll simplify the numbers. Once you factor out a GCF, or there isn't a GCF, you're going to look to see how many terms are you left with. If you're left with two terms, in other words, there's a binomial that's there, you're going to check for either a difference of two squares or the sum and difference of cubes. Because again, remember that those have a very specific formula that you're going to utilize to factor those, okay? If you have three terms, you're going to look for patterns as well. You're going to look for a perfect square trinomial. And if it's not a perfect square trinomial, then you're going to do traditional factoring. And again, the factoring is going to be the kind that you do when A equals 1 and when A does not equal 1. Obviously, remember that when A does not equal 1, it's a little bit tougher. There's guessing and checking, and then there's expanding it to group. But again, you're going to have to remember all those processes. And then if there's four terms, then you're just going to factor by grouping. Okay, so again, you got to kind of master within each kind. With two terms, what are the patterns for sum and difference of cubes and difference of two squares? With grouping, you want to master the process. And with three terms, obviously, if you can identify the perfect square trinomials, you'll get your answer quicker. And if you have to do the traditional factoring, make sure that you know how to do both methods. Again, just remember your steps, remember what to look for, and remember the most critical, I think, is always remembering the GCF. Okay, so let's kind of show you what we mean by factoring completely. So notice here on this page, the first two are binomials, but I look at them and I ask myself, is there a GCF? And I quickly notice that 12 is a GCF for both of them. So I do factor out the 12, and I get 12 times x squared minus 4. Now, in the other slides, in the other lessons, you probably would have been done at this point. However, notice that you're still left with this binomial, and you have to ask yourself, can that binomial be factored further? And the answer is yes. Notice that it's a difference of squares. The first term has a square root, the second term has a square root, and it's separated by a minus. So we know that this is an x plus 2, x minus 2 problem. And so now we factored it completely. So from step 1 to 2 here, we factored it, but we didn't fully factor it. In this last step, it's now been fully factored. So we go to number 2, same thing. We see that there's a GCF of x, which leaves us with x squared minus 16. And then again, we ask ourselves, can x squared minus 16 be factored more? And yes, it can be, because it again is a difference of two squares. And so it's an x minus 4, x plus 4. And so this is the final answer. Now with number 3, again, we come into this problem and we ask ourselves, is there a GCF that we can take out of everything? And I don't see one. Then we say, okay, it's a trinomial. Is it a perfect square trinomial? Potentially, but something that's throwing me off, and it might be throwing you off, is this negative 9 at the beginning. Again, we don't like that first term to be negative, and so what I do whenever I see this negative there, I just factor out a negative 1. If there's no other GCF, I just pull out a negative 1. That's going to change the signs. 9x squared minus 6x plus 1. It's going to change all the signs within the parentheses. And now I'm going to be left with this trinomial that I can either factor the traditional way, or I can try to see if this is one of those perfect square trinomials. Remember that the perfect square trinomials, if the first term has a square root, and it does, it's 3x, right? Because it's 3x squared. If the last one has a square root, and it does, it's 1 squared. And if the middle happens to be 2 times the first one times the second one, or the last one, right, the a and b, and notice it's 6x, then this is one of those perfect square trinomials. Because this is a minus, I know that this is a 3x minus 1 squared. And so I was able to factor it remembering that rule. Again, for a lot of you that don't memorize that rule, because it's not an essential one to memorize, you could have just factored this a little bit more old school. You could have said to yourself, well, what numbers multiply to 9, add up to -6? And so you're like, oh, that's -3, -3. So you could have expanded the 9x squared to -3x, -3x, and then the last term stays -1. Remember, first term and last term stay the same. I expand it out, and what I do is I utilize grouping. Oh, and I have to use the plus that's here. Sorry, that has to be a +1 there. And so, because I took the -1 out, I kind of have to use this. I can't really use that anymore. So anyway, so when I go to factor this, I take the first two and I factor out the GCF, and I get 3x minus 1. I factor out, let's say, a -1 here. That leaves me with 3x minus 1. So my new GCF is 3x minus 1, and it leaves me with 3x minus 1. And notice that that's exactly, plus the -1 out here that I kind of have to bring down and not forget that I pulled it out. But notice that I get the same answer. So I could have gotten the -1 times 3x minus 1 squared the traditional way, or I could have done it by memorizing the formula. Either way, you're going to get the same answer. One is just much quicker. All right, again, so we keep going here. Factor completely. Again, step 1 is always to factor out a GCF. Now for me, before I even do that, I'm going to write it in standard form. So I know the 3x minus 3x cubed goes first, the 9x squared goes second, and the 12x goes third. Now I'm going to take out a GCF, and since this leading term is negative, I'm going to take out a -3x. That's going to leave me with a positive x squared, a -3x, and a -4. And so now I'm ready to factor this traditional trinomial, which I know is going to be, remember, it has to have a product of -3, a sum of -1. So it's -4 and +1. And so I know that this is going to give me the correct answer, and there's my factors. So again, on this one, this last one, there are a couple of ways that you can do this. I mean, there is obviously the longest way to do that is to expand this out, combine all your like terms, and factor your new trinomial or whatever you end up with. Now, that is not going to be the most efficient. So what I want you to think of is I want you to notice that this is really a binomial. So what we've got in this situation is really term 1 here. Let me do this. This is the first term. It just happens to be an expression. And this is the second term. Okay? And notice that they're separated by a minus sign. So does the first term have a square root? Yeah, this is x squared plus 8 squared. So the square root of that is obviously x squared plus 8. Does the second term have a square root? Yes, it would be 6x, because 6x squared gives me 36x. So this is really x squared plus 8 plus 6x and x squared plus 8 minus 6x, if that makes sense. Think of it this way. If I just switched out this entire expression for the letter y, if I had y squared minus 36x squared, you would know that this would be y plus 6x and y minus 6x. Now all I have to do is switch y back out for what it was originally. It was originally x squared plus 8. So see if that kind of makes a little bit more sense, right? Now I'm switching again. X squared plus 8 minus 6x. And that's kind of what I got both times. Now I don't need the parentheses within. And I can actually take each of these parentheses and put them in standard form, right? I'm going to do the same thing to the second one, x squared minus 6x plus 8. And notice that these parentheses are actually factorable. This one here factors to x plus 4 times x plus 2. And this one over here factors to x minus 4 times x minus 2. And this is the fully factored form of this original thing. Now, not an easy solution to get to, kind of complex, but again, if you just take your time and notice that the expression squared is still just one term, it makes it a little bit easier. And then again, we go to the last ones where we have a couple more here. Again, we're always looking for the same types of strategies, putting it in standard form, factoring out potentially a GCF. In number 6, it is in standard form and there is no GCF to pull out, but you recognize that there's 4 terms here, and so you're going to utilize grouping. So you're going to take the GCF of the first 2 terms, that's going to leave you with 3x plus 1. You'll take the GCF of the second 2 terms, that's going to leave you with 3x plus 1. And then you notice that 3x plus 1 becomes your GCF. You pull that out, and it's going to leave you with x squared minus 9. Now here you might want to say you're done. However, you always have to inspect your solutions and see, can I go further? And notice that the second binomial, x squared minus 9, is a difference of 2 squares. It's x plus 3 and x minus 3. And so now you got to your final answer. So yes, this one was factored, right? But this one is what's called fully factored because we got all the way down, and obviously this is the preferred answer. And again here, because these look weird, I know there's expressions here, it's a little bit complicated, but notice that what you've got working here is this term here plus this term here. So it really is kind of a binomial. I mean, there's a binomial within a binomial, but the overall thing is a binomial. And so what you want to be doing is you want to try to see first, can you factor out a GCF? And notice that each one of these has a 2x minus 1. And so that's going to end up being your GCF here. So if I take out the expression 2x minus 1 out of here, that's going to leave me with 4x. If I take it out of this one, it's going to leave me with an additional 2x minus 1. And so, again, I can simplify the inside of this parentheses. It's going to be 6x minus 1. And that's the factor. That's the factored form, the fully factored form of this. And that's it. So